Assalamualaikum. Today we are going to present on our project, which is the operating of hair dryer system, and it will conducted by Siti MAISARAH binti Muhammad NAZRI, Muhammad AL-AMEEN bin AZME, Muhammad FARIS AKMAL bin SHAHARI, and Izzati Nurina An-Nur binti LATIF. Introduction. A hair dryer, also known as a blow dryer, is an electrical device used to dry and style hair. It uses an electrical fan to blow air across a heating coil. As the air passes through the dryer, it heats up. In daily life, people with long hair have higher requirement for hair dryer. The trouble with long hair is the hair dries slowly. Holding the hair dryer and buzzing for more than 10 minutes, it is very important to choose a suitable hair dryer. Next, the problem statement. The regulated heat is only available in low, medium, and high temperature, which is the biggest problem. Other than that, the microprocessor control heat volume might not suitable for everyone have problems. This issue may be resolved by changing the code number in EZ668K to regulate the fan speed and make sure that the heat is suitable for all hair types. Objective. First, to determine the input and output required for a hair dryer system. Second, to obtain the ability to write a MC68K assembly program to achieve the operation in hair dryer system. Third, to be able to simulate the input and output for hair dryer system.
Assalamualaikum warahmatullahi wabarakatuh. So right now I want to share the component from this filler table, which is facts and ideas. The first facts, microprocessor is controlling unit of a microcomputer. The ideas for the first facts is the microprocessor fetches those instructions from the memory, then decodes it and execute those instructions until stop instruction is reaches. Later, it will send the result in binary to the output port. For the second facts, microprocessor process. So for the ideas is microprocessor don't cost much to produce. This means that the use of microprocessor can greatly reduce the cost of the system is used in. So the third fact is program simulation using 68K, which is the ideas is a simple coding system. So the last fact is time delay operation, and the ideas from the facts is timing delay has been injected in microprocessor operation. So that's all from me. Thank you.
Hi and Assalamualaikum. So for flowchart, as we can see, we started by turn on the hair dryer and we enter the speed that we want. We can choose either input 1 for a slower speed or input 2 for a faster speed. Okay, so we start by wanting a slower speed. So we press 1 and then we enter the temperature part. For temperature, we can choose for a lower temperature or high temperature. Because we want to dry our hair faster, we choose a high temperature. So our output will be a slower speed with a high temperature. For last, we end our flowchart by turn off the hair dryer. Then for schematic diagram, it is a closed loop feedback control system. So after reference input, we will meet a summing point. And then there is an Arduino based control which monitors and regulates hardware. The temperature is continually calculated and regulated by the temperature sensor such as K-type thermocouple. K-type thermocouple is interfaced with Arduino Uno board using MAX6675 module. The Arduino controls the frequency of 230 volt AC power hair dryer, which is why it is needed zero cross detection, so we use a full bridge rectifier and photocoupler, and then we get the output that we want.
Assalamualaikum, and in this video I like to share about a code of a DIY codeless for EV68K. So I want to share a code. So this is a code for DIY codeless We start from origin, handle the 1000 start. So the declaration part, we put a button EQU, handle the E00012 LED EQU, handle the E00010. For segment 1, EQU, handle the E0000. Segment 2, EQU, handle the E0002. Segment 3, EQU, handle the E0004. And segment 4, EQU, handle the E0006. Segment 5, EQU, handle the E008. And segment 6, EQU, handle the E00A. Segment 7, EQU, handle the E00C. And the last one, segment 8, EQU, handle the E000E. So in the initial condition, we move the data to the address register. So we move B channel 01 D0, move B channel 01 to D1, move B channel 03 to D2, move B channel 05 to D3, move B channel 09 to D4, move B channel 06 D5, move B channel 0F D6. So this is a main loop, main component in this coding. The code is move B 0 channel 00 LED compare.b button D1 BEQ on compare.b channel 00 button BEQ off compare.b button D2 BEQ split 1 compare.b channel 0B button BEQ H1 compare.b channel 13 button BEQ H2 compare.b button D3 BEQ split 2 compare.b channel 0D button BEQ H3 compare.b channel 15 button BEQ H4 programming. This is for button on. We push a button on and the LED is light. And for this one, the button is 00 and the display is off. So this is button for D2 at the register. D2 is 03 and the speed 1 for the speed 1 and a button for 0B for H1 and button for 13 for H2. D3 is 05 and display for speed 2 and button 0D for H3 and button for 15 is H4. So we go to the subroutine on move B 00 segment 1. So this segment we don't use. We use just segment 4 and segment 5. So I just say we can type in the coding also move B channel 3F segment 4 and move B channel 37 segment 5. Programming. So the for off routine is we don't use segment 1 to 3 and 7 So H, we just use segment 4, 5, 6. So move B, channel 3F, segment 4. Move B, channel 7, 1 for, for segment 5. And move B for segment 6, 7, 1. So this is data we build in the display is this 3F is a 0, is a O, and 71 is F, 71 is F. Also like on, 3F is O and 37 is N. So we go to the speed one, roll dot B 1 D0 in a decimal, and move dot B DO to the LED, and BSR back to subroutine for low. Also, we just use move B for display, and we just use segment 6 for display, move B, channel 06 on the segment 6. So Brahmin. For the height, for the heat one, so this heat, we just have a 2 heat, low and high. So these 2 heat for the speed one. So the coding is roll.b 1 to d5, move.b d5, LED, BSR low. And we use move B 30, channel 38 to segment 2, move B channel 3F, segment 3. And also, you don't forget the segment 6 for speed 1. At the segment 6, move B channel 06, segment 6, bra main. For hit 2, roll.b 1 d6, move.b d6 LED, BSR low. And we use segment 2, segment 3, and also segment 6, move.b channel 76, segment 2, move B 30, channel 30 for segment 3, and move.b 06 for segment 1. This is for the speed 1, 06 at the segment 6. So we go don't forget the Brahmin, and we go to the speed 2. Speed 2, ROL roll.b 1 D0, move.b DOLED BSR height, move.b channel 00, or this segment we don't use, so you can delete or you can also type for to see we see clean coding. So we just use segment 6, move.b channel 5B, segment 6, main. So for the hit 3 ni just for speed 2. So it's for hit 3 is for low, and hit 4 is for high. ROL.b channel 1 D5, move.b D5 to LED, BSR high. And move.b and for hit 3 use segment 2, segment 3, and segment 6. Move.b channel 38, segment 2, move.b 3F, segment 3, and move.b channel 5B, segment 6. 5B is for speed 1, speed 2. I'm sorry. And hit 4, roll.b 1 D6, move.b D6 to LED, BSR high. And move.b channel 76 for segment 2, and move.b channel 30 for segment 3, and also MOHD $5B for segment 6, and Brahmin. Don't forget the Brahmin. Brahmin is back to main. And we have a speed and delay for low and high. Low move.L $9000D7 and delay at I.W1D7 PNE delay RTS. And H1 move.L $C000D7 delay 3 at I.W1D7 PNE delay 3 RTS. And for the coding, we can start the simulation. So first we run the simulation, we execute the simulation, we execute the coding, execute after execute and run the coding, view, go to hardware. So you see the IY cordless hair dryer is off. So we have to press a button to on the hair dryer. To on, we press a button 1 for a speed fan at level 1. This is a speed fan at a level 1, so the LED rotate to the left. So I want a temperature. I want heat, so I press a button 3 for heat. So this is heat for low heat. Speed 1, low heat. So the LED becomes 2 for the low heat. So I want to use the high heat. So the LED becomes 4 for the high heat. I want use for speed 2. So this is a speed 2. The LED become faster. And then I want to, at level 2, I want to use low temperature, low heat. So the LED becomes 2 and faster. So I want to do high heat at level 2 speed fan. So the LED becomes 4 and faster. Alright, that's all. So we just turn off for the head dryer for the safety. Alright, thank you.
Conclusion. So we can conclude that all the objectives of this project are fully achieved. As we know, the hair dryer is good if you use it well, as it prevents bacteria from accumulating on the scalp. And that is a great help for girls suffering from fungus, dandruff, irritation, or other problems on the scalp.
That's all from us. Thank you.